Hi everyone. In this video, I'm going to be taking you through my latest frame design, the AOS 3.5. Now, if you're a pilot who wants the absolute best flight performance for freestyle flying that you can get under 250 grams, then this is the frame for you. I'm going to be taking you through every aspect of the frame design, and I'm also going to be showing you an example sub 250 gram build that I've done of this quad. There are links down in the video description to where, if you like the frame, you can buy it, as well as all of the components that I'm going to talk about in this video. So let's get into it. So before I get into the frame analysis, I'd like to explain why I've selected 3.5 inches as the optimum diameter for a sub 250 gram freestyle build that's targeting maximum possible flight performance. Now, this graph is reproduced from an analysis that I did looking at how prop diameter and quadcopter weight relate to flight performance. And these curves that you can see here are curves of constant disk loading. And I found that disk loading was a parameter that was most comparable between quads of different weights and different sizes to predict flight performance. And what I found was that given current motor and battery technology, the best flight performance for a quad that is carrying a GoPro tends to sit on this blue line. And for quads that don't have to carry GoPros, I found that most of them can sit on this green line. And if you go much higher than this green line, you tend to run into too many compromises to do with durability and motor torque and things of that nature. And if you drop too far below this blue line, you tend to run into issues with not having enough thrust to weight ratio and getting hot motors and things of that nature. So if we look, we're not going to be carrying a GoPro on this build. So if we look on the green line and track it back to 250 grams, we find ourselves almost exactly at 3.5 inch prop diameter. It's not exactly 3.5 inches, but it's pretty close. And so that's why the AOS 3.5 exists. With that said, let's get into the frame design. All right, so I'm excited to talk you through the design of the AOS 3.5. And we're going to start with the frame and the arms in particular. So the AOS 3.5 shares the same arm configuration as its larger brother, the AOS 5.5. So you have 4 separate identical arms that are held in by these sandwich plates here. And having separate arms is really, really great because there's 2 main benefits. The first is that should you damage an arm or break an arm in a crash, it's easy to replace it. It's just these 2 screws. You undo them, take them out, and then you can replace the arm. And neither of these 2 screws is shared with any electronics that are inside the quad. So it's really, really simple to replace an arm. And I think this is a key benefit that this frame design has over something like the Emax Babyhawk 2 HD or the GEPRC Smart 35. They both have arms that are part of the bottom plate. So if you break an arm, the whole frame has to be completely rebuilt. You have to buy a whole new frame. Whereas if you break an arm on this quad, it's really simple just to swap 2 screws and then the arm, and then you can repair the quad really easily. The arms are going to be available as spares as well. So you can buy some separate arms to have in case you break one. The second benefit of removable arms is that a frame with removable arms always has better vibration and resonance characteristics than a single piece bottom plate, all else being equal, because those extra joints between the arm and the frame allow a little bit of movement, a little bit of friction, which dissipates vibration. The arm is a triangular truss shape, and this is the same as on the AOS 5 and the AOS 5.5. And there are 3 key benefits to this triangular truss shape. The first is that it allows you to individually tune the resonant response of two key modes of vibration. There's a mode of vibration where two opposite motors move up while the other two motors move down. And there's another mode where all four motors move up and down together. And by having these two struts, you can tune those two individual modes separately and make sure that they're far apart in frequency and they don't build on each other, which can be a problem with a traditional ARM design. The second benefit of having a triangular truss is that it's really strong under certain loading conditions. So if you have an impact from the front, ordinarily that would produce an enormous bending moment around the root of a traditional arm, and that bending moment might be enough to break the arm because carbon fiber isn't as strong in bending as it is in tension and compression. When you have a triangular truss like this, that same force is converted into tension in this strut and compression in this strut. And the carbon fiber is quite a bit stronger in pure tension and pure compression than it is in bending. Also, I've chosen the cut direction of this arm to keep the carbon fibers aligned with this strut here, which is going to be in tension, so they give the maximum strength and stiffness benefit. And then the carbon fibers in the strut that's going to be in compression in that loading scenario are at nearly 45 degrees, so they help hold the arm together under compression. The third key benefit of having a triangular truss structure comes when thinking about the torsional modes of the arm. So these are the modes where the motor wants to rotate, rocking back and forward on the end of the arm. Now, if you have a triangular truss structure, you have this wide base here. And this wide base on the arm provides enormous torsional stiffness. And that means that those resonant modes where the motor twists back and forward are pushed up to much higher frequencies, and they're much more easily filtered out, and they don't cause any problem with the flight performance of the drone. On a traditional arm design, those frequencies are much lower and they can cause a bit of a problem. You'll see that the arms share the bunny ear or devil horn motor protection features that the AOS 5 and the AOS 5.5 have, and a lot of pilots are requesting and requiring that the frames that they fly have these motor protection features on, because in an impact situation, they're much happier to have the impact be taken by the carbon arm, because the carbon is much stronger and can resist the impact, than have the impact be taken on the motor bell, because once you get a few impacts on the motor bell, even the highest quality motor bearings will start to get rough and create vibration and noise. So by protecting the motor bell with these protrusions, you avoid damage to the bearing, which is going to make your motor rougher over time. And that will extend the life of your motor and also keep your quad flying its best for longer. So if we come onto the bottom plate, you can see that there's a 20 by 20 millimeter mounting in the rear, as well as a 20 by 20 millimeter mounting in the front. There's also a diagonal mounting for a 25 by 25 millimeter AIO whoop board. So if you like that all-in-one form factor, then that fits this frame as well. If we look now at the top plate, you can see that the top plate has been aggressively cut out to reduce weight as much as possible. And these cutouts have been designed with the aid of finite element simulation to make sure that when removing this material, we're not removing any of the strength or the stiffness of the top plate. There will be a couple of versions of this frame, one with countersunk hardware, which is what I've got here, and one with button head hardware, so you can pick the one that you like. I prefer the countersunk version because it means that there's no risk of the screw heads that are here digging into and damaging the battery when you cinch the battery down onto the top of the quad. There are also cutouts here for where the front camera plates lock into the top plate, and that provides a little bit of extra stiffness and rigidity of both the top plate and the camera plates. So if we look now at the camera plates at the front of the quad, you can see that these are 2mm thick camera plates. And I think this is something that's really been lacking in some of the other 3.5-inch freestyle quads that I've looked at, is they haven't had really good camera protection at the front. And I think, particularly given the current shortage of good FPV cameras, there is something to be said for having these 2mm thick camera plates at the front that really protect the camera. If you do have a bit of a crash, you can be confident that you're not going to wipe out your DJI FPV camera or your Caddx Nebula Pro or any of these other components that are currently pretty hard to replace. Obviously, to save weight, there are some aggressive cutouts in this camera plate design, and there are a few different choices of slot so that you can ensure that whatever camera you choose, you'll be able to fit it in there. The same as with the AOS 5 and the AOS 5.5, I wanted to make the build of this quad as easy as possible. So you have 8 M2 standoffs, and you have 8 screws that attach the top plate, and then 8 screws that attach the arms and the bottom plate to the standoffs. So there are only 16 screws to assemble the whole frame, and it's just 8 on the top, 8 on the bottom, and it's super easy to put together and super easy to take apart should you need to do any maintenance or repair of the quad. Before we get into the build, I'd like to take a moment to be transparent about how I select components for these builds. I start by selecting the components I want to use on the build, and then I reach out to manufacturers and distributors and ask if they would be willing to sponsor components. If a manufacturer or distributor sponsors components, they get their link in the video description for the product. That's the only compensation they receive. I never change my selections based on whether or not components are available for sponsorship. Any components that are not sponsored, I just buy with my own money. So with that said, let's get into the build. Okay, so I'm going to take you through my perfect sub 250 gram build on the AOS 3.5. I'm going to start with the props. These are the Emax Avon Scimitar 3.5 by 2.8 by 3 props. And a lot of 3.5-inch builds are using this prop because it's got a nice light pitch, which helps avoid prop wash when you're in adverse flow conditions, but it's still got plenty of thrust and power for more dynamic freestyle moves that you would typically expect to see from something like a 5-inch build. The motors for this build are the iFlight Zing 2 1404 3800 kV motor. Now, these are really fantastic motors. They've got a lot of power and punch for their size. They also have a few features that I really like. There's an O-ring in here to protect the motor bearing against vertical impact, which is a common way in which motor bearings are damaged. They also have a unibell design with a large open area at the top of the motor for cooling. So you can see there's not much in the way of material that's blocking the air flowing down through the motor, and that allows the motor to stay nice and cool. If you're running an analog version of this quad, or you're running a lighter VTX than this CADX Vista, you might consider going up a little bit and using some of that weight budget that you've saved by having a lighter VTX to have a slightly bigger motor, maybe a 1506, to get even more performance out of these props. So let's talk about the electronics. I wanted to save weight by using a 25mm all-in-one toothpick style board for this design. And this is the iFlight Beast F7 all-in-one. iFlight have managed to cram a 45 amp rated 4-in-1 ESC and a fully featured F7 flight controller onto this 25mm board. And you can see that it's tremendously densely packed with electronics. And iFlight have also used BGA versions of some components to save even more space. This board also has a feature on it that is missing from a lot of all-in-one boards, and that is black box logging. This board has a black box chip on it, which means that you can do proper filter and PID tuning based on data that you've collected from logging. And that's something that you can't do on most all-in-one boards. And if I was to recommend anything, if you were to take just one thing away from this video, please do not even consider buying any flight controller that does not have black box logging on it. Because if you have any problems or you want to try and improve the performance of your quad, you really are shooting in the dark unless you have black box logging. So this is one of very few 25mm all-in-ones that has black box logging. And really, please do not buy any flight controller that does not have either a black box chip or an SD card slot, because it's really just a feature that everyone should have and be using. If we come back to the VTX, this is a standard CADX Vista. I know that you can save some more weight off the CADX Vista by removing some of the heat sinks. I've not done that here because I'm not sure whether everyone who watches this video will feel comfortable removing the heat sinks from their CADX Vista, because it does void the warranty and it can cause it to overheat. But if you wanted to save a bit of weight, you could remove the heat sinks, and maybe that saved weight could be invested into a slightly larger motor. It's connected to the CADX Air Unit Lite camera, because that's one that I just happen to have around. But you could use a Nebula Pro or a Caddx Polar or any other camera that works with the DJI HD FPV system. There's a capacitor here, which is a 470 microfarad 35 volt capacitor. And that came with the Beast flight controller. And I would absolutely recommend always install the provided capacitor, because it will improve the noise performance of the quad and also reduce the risk of any components burning out or being damaged by voltage spikes, particularly in crashes and other things like that, where the motors might be changing speed very, very quickly. The antenna that I've chosen for this build is the iFlight Sigma left-hand circularly polarized antenna. It's a small, lightweight antenna. It's very flexible. And I've tied it to the rear strut of the rear arm. And this prevents any issues with vibrational resonance that can be caused by having a long VTX antenna wobbling out the back here. I'm seeing more and more people having problems with long VTX antennas wobbling around and causing hot motors. So tying it down to the rear arm like this is a good way to avoid any risk of that happening for you. It does affect range to have the active element of the antenna so close to the carbon fiber, but for the type of flying I do, I still have plenty of range, and it's also much more durable to have the antenna in this position. I've never had any problems with the antenna being damaged when it's in this position. If it's poking a long way out, you could imagine a certain type of crash that might snap the antenna off or bend it. That's never going to happen if it's in this position. So for durability and vibration performance, this mounting is good, but not so good for range. So if you're a long range pilot, you'll probably want a different type of antenna mount, but just consider making sure that antenna is stiff enough that it's not going to vibrate and wobble around at the back there. As for receivers, I'm currently using the DJI controller and the receiver built into the CADX Vista. I'm waiting on an order of Express LRS 2.4 GHz receivers, and when they arrive, I'm going to put one of the EP2 receivers in here. That's the one with the small ceramic antenna. That's going to give me slightly longer range and slightly lower latency than the DJI controller. But to be honest, I've found the DJI controller to be more than adequate for this build. The camera that I'm using on this build is the one from the CADX Air unit, and as far as I can tell, it has identical performance and image quality to the Nebula Pro. The final component for this build is the battery, and this is a Tattoo R-Line 4S 850 mAh with an XT30 connector. And the XT30 connector is quite important because it's quite a bit lighter than an XT60. I'm still using relatively thick 16 AWG wire. That's on both the battery and on the pigtail on the quad. And I think when you're talking about 3.5-inch freestyle with 1404 motors, you really do need 16 AWG wire to avoid any risk of the XT30 or the pigtail desoldering itself when you're flying really, really hard at full throttle a lot of the time. So now all that remains is to weigh the build. So I've got a relatively thick rubberized battery strap on here, and the quad comes to 249 grams. And this is the quad exactly as I flew it in my 249 gram flight video. I'll put a link to that down in the video description. If you're looking for the absolute best flight performance out of a freestyle quad under 250 grams, and you'd like to try out the AOS 3.5, then you can order it from CNC Drones today. They have international shipping and you can get it in most countries. If, however, you'd prefer to order from your local FPV shop, please reach out to them, ask them to stock the frame. I am always happy to speak with any distributors and shops that get in touch with me, and I'll make sure they get all the frames that they want and that you'll be able to buy them from your favorite shop. If you like the work that I'm doing and would like to support me, please consider joining my Patreon. Patrons get access to my Discord server, where you can discuss these scientific FPV related topics with other like-minded pilots and myself. And they also get access to sneak peeks of some of the projects that I'm working on. At the moment, I'm working on a 7-inch long-range frame that's turning out to be pretty exciting. So if you don't want to miss that, I'll put a link to my Patreon down in the video description. That's all I have for today. So until next time, I wish you all very, very happy flying.